Hey everyone, welcome back. Today we are going to learn about the most powerful features in Kotlin, data classes and field classes. So let's start with data classes. So what is actually a data class? So in Kotlin, when you just add the data keyword before a class, Kotlin automatically generates a bunch of useful functions for you like toString, equals, hash node and copy. So you don't have to write any of that by yourself. So let's just look at this example. So we have data class user var id int var name string, right? That's it. So that's one line. So now let me show you what this gives us, right? So we have fun main var a user 1a var b user brackets and 2b, right? And then we have what we have created here are two users, right? Which is a is with id 1 and name a, and b with id 2 and name b. So now now when I do println a, instead of getting some memory address garbage, right, Kotlin just gives us user id 1 and name a, right? That's auto generated toString. Then we print ln a is equal to b. This what this checks is the structural equality, not the reference equality. So it is like comparing the actual values id and name, and then it returns false because obviously they are different. So that's the auto generated equals. Now we have the copy function. This is really useful. So now what we have here is var c is equal to a dot copy id is equal to 3. What we have changed here is id 3, right? And then we println c. So c is user id 3 and name is equal to a. So the name stays. So basically what we have here is that the name stays the same. So this is really useful when you are just working with immutable data and you just want to change one field. And at the last we have destructuring. We have val id name equals to c println dollar id dollar name. Then Kotlin lets you just unpack this whole thing, right, the object directly into variables. So id gets 3 and name gets a. So it is just more cleaner and readable, right? And then to summarize is that a data class gives you toString, equals, hash node and copy, and destructuring, so all for free, right? So we can use it whenever your class is mainly the holder of data, as we have seen here. Alright, so we have let's run this code and see the output, right? So line 1 is toString, which is working perfectly as we can see here. And what line 2 is equals. So what it does is comparing the values, we can see. So now I want you guys to take a guess on line 2. Alright, so let me just walk you through it. So line 2 is equals as comparing values, as I said. So it returns false, obviously. And what line 3 does is it just copy and created a new object with id, right, and changed to 3, right? And line 4 is restructuring, which pulled out both values cleanly, as we this is exactly what we expected, right? Okay, so now here's the challenge I give, right? So just given data class song, right, val title string, val artist string, val duration sec int, use copy to create a radio edit version that cuts the duration in half, print both and show that the original is untouched. So the goal here is to test whether you understand copy and does not modify the original, right? It creates a brand new object. So let's just walk through the solution, right? So we created song A with the title S, artist and D and duration ends, right? Then we create B using A dot copy, which is the only thing we change is duration sec, right? Which we set to A dot duration sec divided by 2. So 5 divided by 2 for now. Here we have double, right? So it basically just gives us 2. So the key thing to notice is A is never touched, but copy always returns a new object. So A stays at 4 seconds and B is the radio at 2 seconds, right? So basically what the point is, a stays at 5 seconds. So that is a pattern you will use constantly in real apps, especially in Android with view model and state management, right? Where you hold a state data class and update it using copy. So I want you guys to just see what I am doing. See, this is what I was talking about. This is user 2, right? This we have duration sec divided by 2. This is what we have done here, right? And we can see user 1 is untouched and copy returns a new object. So user stays at 5 seconds and B is the radio edit at 2 seconds. We can see here, right? So let's just check it out. Alright, so let's just run it, which is song title equals to S, artist is equal to D, duration sec 4, right? Duration sec 5, sorry. And song title S, artist D, duration sec 2. So basically, original is untouched and duration is still 5, and radio edit is duration is 2. So copy did exactly what it's supposed to do. Alright, so now let's talk about sealed class, and this is where Kotlin is, really expressive about, right? As sealed class, what sealed class basically does is it is a restricted class hierarchy. What it means is that all subclasses of this sealed class must be defined in the same file. This thing gives what it gives the compiler is a complete knowledge of every possible subtype, and because of that, when you use a when expression on a sealed class, right? And see, you don't need an else branch when you use a when expression, as you can see here. So what it does is that the compiler already knows every case. So let's just look at this example. So we have a sealed class res with 3 possible states, right? So we have state, error and stopped. Now notice that stopped is an object and it is not a class because stopped has no data. So basically it is a singleton state. Now look at this function. So we have function me state and res name string. Obviously we want the output in string, right? And then we have used the when state, right? Which is success returns success, error returns error, and stop returns stopped, obviously, right? So no else because the compiler is already satisfied because it knows that the only possibilities are success, error and stopped. That is the power of sealed classes. So if success return as it is, right, and if error is replaced it with a generic failure, right, and if stopped is converted it to success. So this is the pattern which we use everywhere everywhere, like real Kotlin projects, API responses, UI state, navigation events, and anytime you have a fixed set of states, right? And sealed class is what we use here in these type of cases, right? As we can see here, when state is what we have given here, state res name string, as we can see, that's what we are using in when state. Is success return success, and is error return error, right? And stopped return stopped, right? That is basically what we are doing here. And now let's just take a look at it. Alright, so let's look at our force sealed class challenge, right? What is here is write a sealed class network response with 3 subtypes success, right? And val data t, http error, val code, val body, right? And network error, val exception, which is throwable. And then write a when expression that maps each to a user friendly string and verify a compiler doesn't require else. So this challenge is basically introducing generics on a sealed class. So let's just break it down. And sealed class network response out t, data class success t, val data t, and we have then the network response, right? T and brackets. And now what comes after this is data class http error, right? In under this we have val code, which is an integer, val body, which is a string, right? And again network responses, and for now inside it we put nothing, because basically we don't know what the output will be, right? What basically it will be there, right, in the error. Then we have data class network error, right? And val exception throwable, and then we have network response and nothing, once again nothing. So out t, as we have seen network response out t in the first line sealed class. So out t means that this is basically a type of parameter that the sealed class can produce values of any type t, but it cannot consume them, right? That's why http error and network error uses nothing. So they carry no data type, right? So they carry no data of type t, right? So now let's handle the function. So as we have seen here, data class network error, as we can see here. Now I just want you to see this, right? And one of the key functions is this only, right? So now we have data class success, data class http error, data class network error. So sealed class, the whole point of sealed classes, it helps in the screening, right? As we can see, the loading of the screen, doing the data on the screen, right? And then we have network error, and basically showing all the errors, right? Throwing a message, that's what exception throwable here means, right? So basically what we are doing here is we are only doing two things: success http error, and another type of error, network error. And here we are done, and let's now handle the functions. Then we have function, right? As we can see here, fun, handle, result, network response, string, result, when result, right? We have returning when result. Basically we do not have to use return here, but we can just use when instead, right? That's more easier for us. So we have used asterisk here as the type, because that's a star projection, as we can see. So what it means is that we accept any network responses regardless of its type parameter. That's what asterisk basically means here, right? And let's just look at no else, right? Because we have no else, right? So compiler knows all the three cases. So if you ever had a fourth subtype like to network response later, right, this when will immediately give you a compile error if you add a fourth subtype, so telling you exactly where to handle the new case. And that's a compile times safety guarantee you simply don't get with the regular class or enums that carry data, right? So this is the exact pattern used in production Android apps, right? Retrofit responses, repository layers, right, anywhere. So we will learn this next upcoming videos. As I said, no else needed, because Kotlin just ensures that all cases are covered. So, and this is also extremely helpful and really useful in real world apps like APIs, right? And that's it is a really practical example. That's a really good question if you see. And now our last challenge, right, as we can see, and this one just combines everything. So let's just read it and try to solve it. So we have to create a sealed class called player state with playing val var name, string val elif seconds, right, as integer, and then paused val track name and val is elif second, right? And then we have stopped. So we have to write a describe and toggle functions. Okay, so let's just start with it. We have sealed class player state, as we know all this, right? Then we have data class playing val track names, string type, right? And then we have val ellipse sec, right, which is a integer type. And then we have player state. The next data class we will use is data class post val track name, again integers, again string as the data type, val ellipse string sec integer data type, player state, right? And then we have at the end, very end, we have object stop and player state. So this is our sealed class and data class, and then we have object stopped. Now what we will do is that now what the question says, that we have to describe functions and return a message for each state, right? So we have to write describe and toggle functions now. So let's just begin with it. We will do fun describe. So describe function. So what we have to do here is return the message for each state, right? So fun describe, then we have state, player state, string data type, then equals to when state of course, and is playing, and then we have dollar state dot track name, right? Because we obviously want that track to be playing around. And then we have is paused at dollar state dot track name, right? Exactly where we want it to stop. And then we have stopped equals to stopped. So what we have done here is playing is just playing up here, paused is being paused, and stop means stopped right here. And so let's now focus on toggle function, right? And this is an interesting one. So what it does is it flips playing to pause, right? And pause to playing using copy, right? As we can just see it here all. Let's just do it. Fun toggle state, player state, right? Of course. Then we have when state is playing, then what we do here is paused, because we want it to toggle, right? Playing and pause. So state dot track name, state dot ellipse sec, right? And then same goes for paused, because we want from pause to playing toggle, right? And then we have state dot track name and state dot ellipse sec for playing. And then at the very end we have stopped and stopped. So when you are playing, toggle creates a paused with the same track name and ellipse sec, right? So the song position is preserved here. So when you are paused, toggle creates playing again, and stopped just stays stopped. This model just exactly works, right, how a real music player works. And because it's a sealed class, so the compiler guarantees you have handled every possible state. So you can never accidentally miss a case here. That's the amazing thing about sealed class. They just make impossible states impossible, right? As you can see. And let's just see this here. And that we can see here, paused, right? And the same goes here. We have when you are paused, toggle creates a playing again, right? As we can see here, right? And that's a wrap. Data classes for clean, right? Sealed classes for safe, and exhaustive state modeling. So like and subscribe to my channel and drop any questions you have.